All right, good afternoon, everyone. Welcome to our first colloquium series of the winter semester. My name is Omolade Adumbi. I'm the director of the African Studies Center and professor of Afro-American and African Studies here at Michigan. So we're delighted to see all of you here joining our winter UMAPS cohort. So first, I would like to begin by saying a big thank you to the Office of the President, Office of the Provost, the Department of Afro-American and African Studies, College of Engineering, Center for Health and Reproductive Training, Center for Global Health Equity. All of these centers across our university campus supports the UMAPS program and helps in bringing all of these excellent scholars to the university this semester. But at the same time, I would like to show appreciation to the families of the scholars who are here. I mean, the scholars who let them come spend their semester with us at Michigan here. So, of course, as you all know, it's a difficult thing to leave your family behind for a few months. And a few of our scholars have to leave their family behind to be with us this semester. So we're grateful to the families of the scholars back home. So, and to today's business, so we have 4 of our scholars who will be presenting this afternoon. And the format is that I'll introduce all the scholars, and each will take turn to present their work. That should take 15 minutes. At the end of the presentation, we'll have a panel discussion, and we'll open it up for questions and comments from the scholars. So please wait until the end of the presentation before you ask your questions. But first on our list is Dr. Marissa Balmith. So Dr. Balmith is a lecturer in pharmacology at the University of Pretoria, South Africa. She holds a PhD in pharmaceutical chemistry from the University of KwaZulu-Natal, also in South Africa. Our research interest centers around silico-molecular modeling, drug design, and cancer metastasis. And at Michigan, Dr. Balmith is working on a project titled Molecular Mediators of Cancer Metastasis. And Professor Max Wicher of the medical school is our host. And we're happy that the host is here with us this afternoon. But this afternoon, Dr. Balmith will be presenting a paper titled The Role of the Estrogen Receptor in Breast Cancer Dormancy. Please join me in welcoming Dr. Balmith. Next is Tesfaye Wondyifraw Segaye. Tesfaye Wondyifraw Segaye is a senior lecturer in the Department of History and Heritage Management at Debre Marcos University, Ethiopia. He holds an MA degree in archaeology from Addis Ababa University, also in Ethiopia. And at Michigan, he is collaborating with Professor Brian Stewart of the Department of Anthropology on a project that centers around exploring and evaluating the newly discovered rock art site in East Gojam, northwestern Ethiopia, with the objective of working towards its preservation as a cultural repository. And his presentation this afternoon is titled, The Newly Discovered Prehistoric Art Paintings Along the Valley of the Blue Nile. Please, let's put our hands together for this guy and Professor Brian Stewart. Next is James Orwa. James Kenyatta Orwa is a senior instructor of biostatistics at Aga Khan University, Kenya. He received his Master's of Science in Biostatistics from Hasselt University, Belgium, and is currently a PhD candidate in Public Health at Ghent University, also in Belgium. So at Michigan, he is collaborating with Professor Agbawalji of the medical school on a project relating to artificial intelligence and machine learning approaches for the identification of predictors of maternal neonatal and child health risk. His presentation this afternoon is titled, Comparison of Machine Learning and Logistic Regression as Predictive Models for Adverse Maternal Outcomes of Deliveries, a hospital-based retrospective study. Please join me in welcoming James. No. Last but not the least is Jean-Pierre Gendahayo. Jean-Pierre Gendahayo is an assistant lecturer in applied mathematics at the University of Rwanda. He holds MA and BA degrees in mathematics and statistics, respectively, from the same University of Rwanda, where he is also currently enrolled as a PhD student. His research centers around mathematical and scientific computing in the areas of epidemiological modeling and the so-called inverse problems. At Michigan, he is working on a project titled The Solution of Two-Dimensional Transient Inverse Heat Conduction Problem, and is working with Professor Divakar Viswanath of the Department of Mathematics as his host. His presentation this afternoon is titled Estimation of Surface Temperatures from Nonlinear Heat Conduction Models from Quenching Applications. Please join me in welcoming Jean to our Colloquium series. And as I said earlier on, each of our scholars will have 15 minutes to present their work. At the end of all the presentations, there will be a Q&A session. And also, I would like to recognize some of our participants who are online. And please, if you have questions at the end of the presentation, just use the Zoom raise hand icon to ask your questions. And someone will be there to read the questions out to all of us. So thanks, everyone. And first is Dr. Fallad.
Good afternoon, everyone. Can you hear me? The back? Okay, great. Good afternoon, everyone. Within today's presentation, I'm going to be providing an overview of the research that I've been working on at the Wisher Labs, focusing on the role of the estrogen receptor in stemness and ER signaling. Now, it is well established that cancer is daunting in the breadth and scope of its diversity. It's spanning genetics, cell and tissue biology, pathology, and its response to therapy. Apologies. Thank you. Statistics from the SEER database reveal the 5-year relative survival rate for breast cancer in the United States based on how far the cancer has spread. So if you look at the image on the slide, the 5-year relative survival rate for localized female breast cancer was found to be 99%. And as we progress through these stages, we see a decrease in this percentage. Of note here is the distant stage, whereby cancer is spread from the primary to the secondary site in a process known as metastasis. Also included on the slide are some statistics showing the cumulative risk and annual rates of distant recurrences in breast cancer patients every 5 years over a period of 20 years, and this is based on the nodal status at the time of diagnosis. And what we see here is distant recurrences were found to occur steadily throughout this 20-year period. Now, these statistics emphasize the need to have a better understanding of the molecular mechanisms underlying the disease process. The focus of the study is on breast cancer, with particular interest in slow cycling or dormant cells. Now, these can be best defined as cells that have broken away from the primary site and has taken up residency in secondary sites where they later reawaken to form metastatic tumors. Dormant cells are believed to play very important roles in therapeutic resistance, whereby your cancer cells no longer respond to therapy, as well as relapse or recurrence. Now, in women with estrogen receptor positive breast cancer, these dormant cells are believed to drive late relapse following adjuvant therapy, placing these women at lifelong risk for cancer. The cellular source of that late relapse is believed to be attributed to these disseminating tumor cells, denoted DTCs, that are found in the distant sites, as approximately 60% of estrogen receptor positive patients with metastatic relapse exhibit bone metastasis as their first site of cancer recurrence. So in order to be dormant and to be able to survive in a foreign environment of a metastatic niche, these cells must have plasticity. Plastic cells include cells like cancer stem cells that are capable of tumor initiation and the generation of functional heterogeneous cell populations. Research by the Wisher Group and others have shown that in breast cancer, there is this hierarchical organization that is driven by these cancer stem cells. So these cells not only play a role in tumor growth, but have been implicated in therapeutic resistance as well as metastatic relapse. Cancer stem cells may arise when cells undergo dedifferentiation during a process known as epithelial mesenchymal transition. So this is a biological process in cells whereby epithelial cells lose their characteristics over here, and they adopt a more invasive migratory phenotype to become mesenchymal stem cells. Of interest to us are the mesenchymal breast cancer stem cells because they define this slow cycling quiescent state where they invade locally and they disseminate to those distant tissue like that of the bone marrow. So understanding how these disseminating tumor cells basically remain dormant and later emerge from a state of dormancy to form clinically metastatic lesions is extremely important when working towards strategies at targeting late relapse in these patients. So this study is based on the hypothesis that the dormant breast cancer cells exhibit similarities to your mesenchymal breast cancer cells. So especially the quiescent mesenchymal breast cancer cells. We go on to hypothesize that the bone marrow creates a microenvironment or a niche that supports long-term dormancy, and that under conditions of oxidative stress, there is a transition in these mesenchymal breast cancer cells from a partial EM state to a hybrid EM state with activated estrogen receptor signaling and ultimately reawaken from dormancy. So there has been clinical evidence linking the estrogen receptor to dormancy, and there's also been ontological evidence linking stemness to dormancy. So the question that we're trying to answer in the study is, how does estrogen receptor signaling relate to stemness in dormancy? In order to do this, we set aside the following project goals. The first is to determine if green fluorescent protein is expressed in an MCF7 dual fluorescent reporter cell line. Next, to determine which population of those MCF7 cells are stem-like. Thirdly, to determine whether treatment with an estrogen receptor antagonist like fulvestrant can inhibit the estrogen response element activity and subsequent sphere formation in MCF7 cells. And lastly, to investigate how these mesenchymal breast cancer cells and estrogen receptor signaling regulate tumor dormancy and reactivation in the bone microenvironment in immunodeficient mouse models. In order to do this, we conducted cell culture. This is a technique that we use in the laboratory in order to study cells outside of their natural environment to enable us to study their behavior and characteristics under very controlled conditions. So if you look at the image on the slide, this is an example of the luminal A MCF7 breast cancer cell line. This is an image of it under the microscope, and this cell line expresses the estrogen receptor, which is of interest in the study. Next, in order to track how the activation of estrogen receptor signaling affects the maintenance of these mesenchymal breast cancer cells and tumor dormancy, we conducted viral transfection or transduction, which involves utilizing viral vectors to study gene function and expression. So there are two particular genes we're interested in looking at here. It's the vimentin gene, which essentially is an EMT marker. So we use it as the primary readout for stemness. So it reports on those mesenchymal breast cancer stem cell activity via IRFP expression, and that is our fluorescent marker, which will fluoresce red in color. Then we have the estrogen response element, which speaks to the activation of estrogen receptor signaling via the green fluorescent protein, and what we will see here is green fluorescence. So in order to do this, we took a recombinant lentivirus expressing the green fluorescent protein that's driven by an estrogen response element, and we introduced it into our Vimentin IRFP720 reporter cells. We then conducted blastocidin selection, so it's an antibiotic selection technique that allows us to select for those cells that have successfully taken up our DNA construct. And in doing so, we were able to establish a Vimentin IRFP720 ERE-GFP dual reporter cell line, which was used in our subsequent experimentation. We then conducted fluorescence-activated cell sorting. So this is a specialized flow cytometry technique that enables us to study specific genes that are tagged to those fluorescent markers. So if you remember, we're looking at Vimentin, which is tagged by our IRFP720, red in color, and the estrogen response element, which is tagged with the GFP, which is green in color. So this enables us to sort those heterogeneous population of cells into their various populations. So I've included an image on the slide. This is an example of a sample that has been analyzed, and this is to help orientate you with reading out some of the results. If you look at the first quadrant, the cells in this quadrant express the IRFP720, but they do not express GFP. The cells in this quadrant represent cells that are bipotent. They express both IRFP and GFP. If cells are found in this quadrant over here, they express neither IRFP nor GFP. And cells that are found in the last quadrant over here express GFP, but do not express IRFP. So some of our preliminary data showed that when we've used a MCF7 parental cell line, so this is our control cell line, it doesn't contain that dual fluorescent reporter, and as such, we should not be seeing the estrogen response element nor the Vimentin here. And so we can see that the cells that did fall in this quadrant are actually double negative. Okay, if you look at cells that contain Vimentin IRFP, these cells essentially should have Vimentin, and as such, we find the expression over here positive for Vimentin expression. However, when we analyzed our dual fluorescent reporter cell line, essentially we would expect that the cell line has expression for IRFP and GFP because it has both the genes. But we were not able to see very strong GFP expression, so only a minimal portion of cells expressed GFP. So this led us to believe that estrogen receptor signaling was actually not functionally activated in these cells in a 2D microenvironment when cells are grown in a monolayer. And the reasons behind this are quite complex, and it's not really well understood at this stage. So we now have a portion of cells that are double negative over here, and we have a portion of cells that do express IRFP but do not express GFP. So we decided to take this population of cells forward in our subsequent experimentation. So we conducted the tumor sphere formation assay or a mammosphere assay, and essentially what it does is it enables us to quantify the number of stem cells in the population and assess their capability for self-renewal. So the assay is conducted under serum-free conditions and under non-adherent conditions, as only cancer stem cells can survive and proliferate in this type of environment. So the assay was carried out on control cell lines that were not treated, and then we brought in our estrogen receptor antagonist fulvestrant at various concentrations. So this was done in order to determine which population of cells formed spheres, which population of MCF7 cells was sensitive to treatment using fulvestrant, and we did this by assessing the morphology of these cells under fluorescent microscopy, but we also did a quantitative estimate of the number of spheres that were formed by this IRFP positive GFP negative population. We looked at the size of these spheres, and ultimately, following dissociation of the primary spheres, we looked at the ability of these cells to form secondary spheres, which is also self-renewal capability. And our preliminary data, if you look at the top two quadrants, these are vehicle-control treated cells, meaning there are no drug here. And basically what we found is that in cells showed very strong expression of the green fluorescent protein. So visually under a fluorescent microscope, we found that over 60 to 70% of our cells showed GFP expression. And then I've also included the second quadrant here with fulvestrant treatment. This is at 5 nanomolar for representation. And we found that the drug was able to significantly inhibit that GFP expression in our cells. So this study is currently in progress. However, moving forward, we will also be conducting some in vivo studies in order to investigate how these mesenchymal breast cancer stem cells and estrogen receptor signaling regulate tumor dormancy and reactivation in the bone marrow using immunodeficient mice. So what we will be doing here is performing an intracardiac injection of fluorescently labeled tumor cells in 2 mice models. So we'll have a control mice that is not treated, and we'll have mice that are treated with fulvestrant over a period of 3 weeks. And after 21 days, we will isolate the bones and analyze the percentage of PKH using flow cytometry, also to determine if metastasis has occurred. So that is pretty much an overview of my study. I would just like to take this time to acknowledge the following people: my host, Dr. Max Wisher, and colleagues at the Wisher Lab for their support. Thank you very much for your attention.
Next is Tesfaye Wondyifraw Segai.
Okay, thank you. Hello, everyone. I'm Tesfaye. My title of presentation for today is the newly discovered rock art heritage along the valley of the Blue Nile and in northwestern Ethiopia. So this is an ongoing research and still I'm working on it. These are the outlines that I'm going to discuss in this presentation. The first one is this, I will try to show the introductions, study area, the method, the study site, and tentative dating, and lastly, the summary. To start with, the introduction, what's rock art? I think it's good to give some kind of definition what rock art is. Rock art is the paintings or engravings that are executed on the surface of a rock, and it is the primary source of information about the prehistoric period. If this is the definition of rock art, what is the motive behind for having rock art? There are different suggestions about the motives of rock art, and the first and the predominant suggestion about the rock art is that art is for art's sake. That means rock arts are executed for the sake of art, beauty, for the sake of art, entertainment. And the second suggestion is that magical purpose. There is a belief that rock art has a magical power in order to attract animals and to facilitate hunting. The other suggestion is that for ritual purpose and for information transfer. Now let's come to the rock art in Ethiopia, how rock art look like in Ethiopia. There are it becomes over 80 years since the first attempt to investigate Ethiopian rock artists. The Europeans or the French were the first scholar who investigated rock art in Ethiopia. And after that, hundreds of rock art sites were investigated in Ethiopia. So Agazi Nagash has clustered these rock art sites into 3 assemblages. The first one is at the northern assemblage, the eastern and southern assemblage, as well as the southern and central assemblages. The northern assemblage consisting of paintings and engravings, and the eastern as well as the southern assemblage, it consists only paintings, and the last assemblage, that is the southern assemblage, consisting only the carvings. So the question here is that what about this part of Ethiopia, northwestern parts of Ethiopia? Here is the map that shows the distribution of rock artists in Ethiopia. As you can see from this map, most of these rock arts are concentrated on the north tip of the country, and in the eastern as well as that of the southern parts of the country. So the question is that the other side of, or the other region of Ethiopia, it was not surveyed for a long period of time, and there was no a single rock art site which is reported over the last 80 years. So this study has revealed that there are lots of rock art sites in this marginalized area, and have discovered 4 rock art sites in this area. Those rock art sites, to name each of them, The one is at the Boitsert, which is already studied and documented, and the second one is at the Janagez rock art site. The third and the one which I'm now investigating is at the Jurusert rock art site, and the other one is at the Kararu site. So within last 4 or 3 years, these rock art sites, new rock art sites, has discovered and they are under examination. Therefore, because of this fact, there is an emerging new assemblage of rock art sites. I show you before that there are 3 rock art assemblages in Ethiopia, but now there is a newly existing rock art assemblages. That is, we may call it as Northwestern assemblage, or we can call it as the Nile Valley assemblages. So this is the study area. The red spot here around the Nile River, we call it Ababa River. The sites are exactly located here, and this study is conducted in the Blue Nile Valley, and the survey began in 2018, and it ended up with the discovery of the 4 sites that I have shown before, and the one is already studied and the other is under investigation. So this is a picture, the partial view of the rock art site. The one which is at the top is the exact rock art surface or the feature of the rock features, and this one is the Nile Gorge or the Nile Valley, which can observe from the site, and I think you can be able to see the rivers here. The picture is unfortunately taken at the dawn of the day, so it's not clear. When the study, the method of the study, it's a kind of documentation. So I have documented each panels which are found on the rock surfaces, and mapping, measuring of sketching, scaling, drawing of the rocks and the panels were done before. And these are some of the materials that I have used for the documentation of the rock artists. To avoid direct contact and further destruction, because rock artists are fragile by itself, I used taking photographs and redrawing these photographs manually by using a supportive app, which is a tracing app, which is called tracing app. Both primary and secondary sources were used, and people were interviewed about the local history of the rock artists. This is the rock surfaces. The sketch plans of the sketch plans that shows the distribution of the panels. There are about 17 panels, and this rock surface are separated by a public road that connected people who are living on in the highland and the lowland area. So I have got 17 panels here, and I'm not going through all of these panels. I will try to show you some of the panels and their paintings. Here is before I go to the each panels, let me say something about that. This site is exceptional in its composition of depicts, predominated by that of symbols. All of the paintings seem to representing the local ecosystems. On this rock surface, I have got the motifs of wild animals like leopard, antelope, and giraffes, aquatic life like fish, hippo, and from the arboreal, monkeys, birds, and from the humans, it looks like boat sailing scenes are there, and animals riding as well as hunting, and exceptionally plants are depicted on the rock art. This is the panel 1, and the painting is over there. As you can see from the painting or from the image, we have lots of geometric figures. From these geometric figures, 4 are crossed circles, 2 are circles with rays, it may be probably sun, and the others are solid circles. Apart from these geometric figures, there are lots of animals like a probable giraffe depicted here. Sorry. And halfly destroyed ostrich, as well as human-like figures. Figures are there. And panel 2, the same thing happened here. There are abstract or geometric figures which are circular, and here is a guy who seems carrying a gun, and he's in a position of hunting wild animals. Here we find an antelope and another animals which is difficult to identify. Right now, this is an interesting panel, I think, because paintings are here very visible, and at the bottom of the panel, I've got here a group of monkeys who are in the position of picking something from the ground, and they are ready to feed it. Unfortunately, one of the painting, one of the monkey seems either falling or in the falling or climbing positions. In the middle, there is an antelope, and at the top of the panel, I've got here a hippo, and there may be running leopards are there. Here is also another interesting or another beautiful images on panel 8, and it represents fish, and there is also a circular lines, which probably be a water body where the fish is living. And panel 9 also another figure here. Here we can see the flying bird, as well as a bird which is sitting on the branch of a tree, and another geometric figures, as well as stylistically running, or the man carrying bows or rows. Here is also another, a probable plant is painted here. Plant is not common in Ethiopian rock art, not only in Ethiopia, in the Horn of Africa, plant is not common. But here it is another report from Jerusalem Caves. Panel 12 is a very difficult animal to identify. It probably be a feline or a wild cat, and here is also another crossed circular figures. Panel 13, I do have here two pictures. The one seems the antelope, a single horned antelope, and here it is a cross-like feature, probably be schematized humans. And panel 14, another geometric figures, 4 circulars, and the fifth one, it has rays, and it may probably represent sun. And panel 5, another animal motifs, which probably be a camel. It is very difficult to say here, because I think it is an early to interpret or to give meanings for this depictus. It is my time to do more on this site. So it probably be camel within her calf in front of her. And panel 16, also another panel which has lots of geometric figures. There are circular figures with rays, and some are inscribed with cross in the middle. And the last panel, that is panel 17 also, the other motifs. It looks like 3 people, 3 schematized or stylized people who are running to a kind of an object which probably be a boat. So now let me come to the dating of these sites. The Horn of African rock artists are tentatively dated by the already established chronology, which is an Ethiopian Arabian style. So this Ethiopian Arabian chronology tentatively dates from 3000 to 400 AD, and this period coincides with the hypothesized migration of pastoral populations into the Horn of Africa. This is the diagram that tries to summarize the rock art style in Africa. We categorize into 4: Saharan style, Horn of African style, Nile Valley style, and South African style. The Horn of African style, in the Horn of African style, we do have the already established style, that is Ethiopian Arabian style. And this Ethiopian Arabian style has 2 stages, the earliest stage and the latest stage. The earliest stage dates between 3000 to 1000 BC, and the earliest stage, the latest stage dates from 1000 to 4 in the 4th century, 4th AD. So in this Dahatamba stage, we do have engravings as well as that of schematized painting, and in the latest stage of the Dahatamba period, we do have geometric figures, and probably this site may fall to this stage, because there are lots of geometric figures represented in these rock art sites, and most probably the the sites fall to this diatomite, the latest phase of the diatomite. That means from 1000 to 4th century AD. To give the summary of this study, except the probable camels, there is no domestic cattle. And because of this fact, the site may probably belong to a kind of the hunter-gatherer groups. Aquatic life like fish, hippo are the first in its kind happening or appearing in Ethiopian rock art paintings. So this may suggest that Blue Nile River was used as a source of food. And most of the paintings are geometrical figures. And these geometrical figures are very difficult to interpret and to give meanings. But to give some hints about these circles are denoting cattle enclosures. And those circles with cross insides are suggested to be cult of the sun. And they are also probably suggest that a morning star, and they are used for brand camels and to appropriate the goddess. Now, I think I'm running out of time. Thank you very much. I would like to thank this African Study Center and the Anthropological Archaeology Museum, especially Professor Brian, my host professor, and Professor Michael Galati, and the SolSAC project. Thank you.
Okay, thank you. Next is Jean-Pierre Ngendahayo.
Okay, thank you. So good afternoon. Yeah, I'm Jean-Pierre Ngendahayo from the University of Rwanda. I'm going to present my topic today, which is called Estimation of Surface Temperatures from Nonlinear Heat Conduction Problem for Quenching Application. So the slide is going to be ready. So normally this problem, it comes from application, for example, in the steel industry. Oh, wow. Oh, well. I hope the slide is ready now. Yes. Yeah, thank you for waiting. So the topic is like estimation of surface temperature from nonlinear heat conduction model from quenching application. So my host is Professor Divakar from the Department of Mathematics. Oh, doesn't work. What's wrong? It's a PDF.
This is the way it is.
Okay. Yep. So let's me taking the background of the project. So this problem comes from application, for example, from steel industry, where they want to control the heating and cooling so that they can have the best product that can be given by at lower price. Now, the problem of surface temperature and or heat flux estimation from interior measurement taken by some sensors, for example, like thermal pulse, it has a lot of application in engineering and science, and the problem is known to be Eid-Pause problem, because like if you are using like sensor to take some measurements, they can have some errors, and the errors they be like amplified when you are trying to find out the solution, and you get some results which are inaccuracy in the solution. Now this problem is known as inverse heat conduction problem when you go to quenching application. So I'd like to take you what I'm talking about. Like, let's try to use this simple geometry. On this left side, here let's suppose that this is a test furnace you can use for heating some material inside. Suppose that you have this kind of steel slab, which are this geometry that are being heated inside here. So this steel, like suppose that you are embedded some 3 thermocouples, like here is a position, like the first sensor at this position. This is another sensor at second position. This is another sensor at third position. You can embed many sensors that you want. And this is a position like x equal to 1, which you consider as the surface, and you want to estimate the surface temperature. So now here you have some kind of like a model equation that can govern this process. Now here you have this kind of differential equation. Here you have this B, which is a coefficient denoting like the property of specific capacity and density. And you have another function A, which is like thermally conductive, the property you are using. So here you have differential of function U, which is not like a function of time and X. So here you have differential like Ux, and these are differential, the second differential of this, all the function product of thermally conductivity, and the first differential of U. So here you consider some boundary condition. This is Ux, which is like the initial temperature and time is equal to 0. And here this is U0T, which is like the surface temperature you are looking for, which is like a function of time. And here you have like URTGT, which is like the boundary for the slab we are using. Suppose that this slab has like a length L, and this will be like the condition on the ending points. So here, if you assume that this given function, initial temperature and F and G, they are known functions given some function space, for example, like in L2, and also have made some assumption on this coefficient B and A, which depend on X, T, and U. So we can say that this problem is well posed. Well posed means that you can have the solution which is unique and it depends on the solution on the data. So suppose that this problem is said to be well posed, then you can try to format like a mapping, which is a map the surface temperature to some interior measurements. Let's say that you take like a measurements between 0 and the length of a slab. Suppose that this slab has the length, which is the unit. Then you can take some measurements inside. Then you can be able to transform this problem into a operator equation that has like Kf, which is equal to G1, which is like the first measurements. So we know that if the operator we can format from this equation 1 here, it can be linear equation if we assume that U0, the initial temperature, G, like the ending point, they are equal to 0. And you assume that this coefficient A and B, they depend on X and time. In that case, the operator will be linear operator. Otherwise, it will be non-linear. So I'll also say that we are trying to take some measurements using some sensors. We can assume that this measurement, they have some error. We can note them as eta, where eta is like a random noise vector. We've known distribution. Sometimes we like to use the Gaussian distribution. We've known variance, which be not by delta. Then instead of having a problem too, we can have like Kf is equal to G1 delta. G delta to mean that it has some noise level. So if you are trying to evaluate this operator K, like it means that you are taking K times F, it's known as direct problem. But if Kf is a given and we want to find what is F given G, to be known as an inverse problem. So normally you can look at this problem as a simple linear equation, which you can use some method from linear algebra to find the solution F given G. But we'll see that this operator, it will be like an EID conditional matrix. If you try to use this operator as a matrix, it will be EID conditional matrix, which means that you have like a big condition number, so it will not be easy to find its inverse. So you can use like the normal techniques from linear algebra. Now, assume that for this level, we are using many sensors like M sensors. Now, our operator you have from here, this K. Suppose that this is a matrix and we're using many sensors. So the matrix to be noted as K1, K2 up to Km to be a matrix of which we have like M times N. If N that is like the size of the matrix, how many number of rows and columns. So this matrix will be like M times N cross N, which is like how many number of measurements you are using and the row of the given matrix. So we assume that F and G, there are some vectors with a given size. Then we can try to find the solution of that system using some standard technique from numerical algebra. So here, if you want to use like single value decomposition method, we can try to write down the solution of that system as F delta is given by this equation, where Vi and Ui are eigenvectors of the matrix. And here you have not like sigma I, those are known as single values. So here I took some simple experiment, and then I took like a matrix of 1,000 rows or 1,000 columns. So if you try to see, I get another matrix of 3,000 rows or 1,000 columns. So I try to compute their single value decomposition. Then I plot single values. You see they are decaying to 0. So even at 300 numbers, these numbers they are decaying to 0, which means that if these numbers are decaying to 0, so not be able to compute this F. So you need to have another method for computing the solution. So one of the methods we know from linear algebra is like you can use what you call Tikhonov regression. So having a solution like this, you'll be solving this minimization problem. So here, I would like to give you some simple examples so I can see what I'm trying to talk about. Here, I took like a simple example where we assume that the slab has a length which is equal to the unit, and the boundary condition Ux is 0, the initial temperature is equal to 0, and the temperature at another boundary is also to 0. Then I take time, which is between 0 and 10. Now the problem one, you can get its discrete form using, like, for example, like Craig-Nicholson method with a grid size of 1,000 for time variable, another one for 300 for space. Then I assume like the function b is equal to 1 and another function ax is this function. Then I choose some simple exact solution which can be given by this function. Suppose that this is like some exact function solution. You see at the starting time, temperature is 0. After heating, it goes up, comes down, it's cooled down to 0 again. So I estimate some data. You see this is like exact solution. This is some simulated data. You can assume that is like the function g. Then you see this function, they have some noise. So I want to construct my solution using this data. So these are being taken of the measurements which is equal to 0.6. Remember our slab has a unit length. And then I took some measurement at 0.6. And the noise level is given by this number, 10 power minus 10, 2.25. So now there is a method for solving this problem. You see, in this equation, you have this parameter lambda. It's called the regression parameter. So you have to be able to know what are the range you can choose so that you can have better solution. So there is a way. You have to choose an interval of these parameters. I have taken from 10 minus 3 to 10 power 0. Then I have this kind of regression parameter. I plotted like the regression solution f delta with the exact solution. You see it's a curve somewhere here. The area there is 0. So I have to choose the best parameter. So there is a technique called like eddy curve. The theory says that the best parameter is somewhere here on the corner. So I use this parameter. The given corner is given by this value, 5.01 times 10 minus 2. And which is assumed to be somewhere here. So here, I try to get the solution. You see in the black, it's exact solution. And the blue one is the computed solution. And this is the measurement taken at 0.6. You assume that the sensor is embedded on 0.6 location. And then this is a solution you can get using the base parameter. And I choose like also another random parameter which is equal to 10 minus 2. And you see the sources are given on the right side in this right figure. This is like the black is exact solution and the blue is the computed solution. Just by seeing by eyes, you can see this is a best solution when you compare this one. Even this one is not better. So now another way is to use more sensors inside. Here I took another example by using 6 sensors. So I get this kind of solution. It's look better, but also not better. Yep. So if you can be able to have many sensors, you can have better solution. So I tried to compute like the error between the regression solution and the exact solution with the number of measurements. You see, if you have like 6 measurements, the error is decaying to 0. They are minimizing. They are minimizing. So the measurements are being taken at 0.6, 0.61, 0.63, 65, 6L, and 0.7. So we can conclude that the more you use more sensors, take the data, you can have the better solution. Now, our aim is to solve some nonlinear case. So the nonlinear case comes when the coefficient depend on x, t, and u, which is like, this is the temperature, like thermal conductivity and specific capacity depend also on the temperature. So to do this, you need some iterative algorithm. So how to do this? We propose that, this is until we are still considering this part. So we assume that we solve this problem using some iterative algorithms by how? So we assume that you have some approximate initial temperature, which is not by U0, and then you can create the iterative algorithm given by this function, UK plus 1 to be given by another function you can call it L just mean nonlinear case, which you accept A, B, U0, and G as some inputs, and then you compute the whole process until the difference between UK plus 1 and UK, the norm, this I'm using like Fibonacci normal, is sufficiently small. So if you can continue, you'll be able to recover the temperature distribution UXT. Once you have it, you'll be able also to formulate the operator K as before for the linear case, and then you can apply Tikhonov organization for computing the solution or another method for computing the solution. So this is what we are proposing to do for this case. I'm here because we still have time to conduct our research. I'm in this level, and I have a draft where I'll try also having some theoretical part of the paper and then have numerical result after. So thank you. But I can also finish my presentation by expressing thankful to my host, and now he's here. Professor Wondyifraw he's now doing a real job helping me to understand this part, theoretical part, by giving me a course of partial differential equation, which is behind of my research. I also thank African Studies Center for inviting me. Thank you so much.
Our final presenter is James Kenyera Orwa.
Thank you.
Good afternoon, colleagues. Thanks so far for listening to us. So this afternoon, I'm going to present to you my proposed work on predictive models. It's a preliminary work though, but it's based on one of the bigger projects called UZIMA. UZIMA means, in Swahili word, which is an acronym, means health. But in full, it means utilizing health information for meaningful impact in East Africa through data science, which is one of the collaborative projects with Aga Khan, Cambridge, Center for Global Health, Michigan, and Dalhousie University. So to start off, progress has been made so far to reduce maternal and newborn child health, but still much work has to be done, especially in sub-Saharan Africa. You've seen daily women still die because of this, especially the young girls and women die yearly. And in the last time we saw the statistics show that over 20,000 of women died. And this accounts for 66% of the deaths worldwide. Of note, this disparity. The disparity in terms of maternal mortality rates in SSA, as you can see in the next plot. So this graph shows the global mortality rate. And you can see the part, this part here is part of the sub-Saharan Africa and some parts of Asia where we have some kind of mortality rate which is very higher compared to other places. So the causes of this is quite numerous and ranges from obstetric labor, induced hypertension. We also have sepsis and you have abortion. If we compare the world, the global maternity causes and the one for USA, we see that if you look at globally, they have the pre-existing conditions, hemorrhage, and hypertension. But look at the developed world, that's not the USA. For example, mostly we have the cardiovascular, non-cardiovascular, and only 14% due to infection. What that this shows? It shows that with a better improved kind of health system, some of these conditions can be prevented. And that's what's lacking in SA Africa. And then that's why what's lacking, and you can see in the other map that I showed that this part here. So it tells us that women in these regions still has higher risk of complications. That results from the preterm births, hypertension disorders during pregnancies, diabetes, and cesarean sections. So then come the SDG, the Sustainable Development Goals. These goals were framed from the Millennium Development Goal. Progress was achieved, but target was not met. Then the thought came of the Sustainable Goal where, again, another target was set. And one of them is to reduce the maternal mortality rate by 70% by the year 2030. Another one is to reduce neonatal by 12 per 100,000 births, and also reduce under 5. So achieving this requires effort. And one of the efforts is to have early and accurate prediction of these conditions. And the conditions during the pregnancy, postnatal, during childbirth, and post-abortion. So with this kind, if we do early prediction, we'll be able to achieve that. So to this end, we have two aims. And one of the aims is to identify factors that are associated with adverse pregnancy outcomes. And the second aim is to compare the performance of machine learning models. So our data came from the registry. We have a registry that was started in the year 2020, and so far we have approximately 9,500 births recorded in the registry. The registry is established in 5 Aga Khan Development Network hospitals that are based in Mombasa, Nairobi, Kisumu, Dar es Salaam, and Mwanza. That's in East Africa. All these are non-profit making institutions. So what happens that any woman that undergoes delivery in these facilities, we administer a questionnaire within the 24 hours of delivery, or we delay in case there's a complications. And then what we collect data on the birth outcomes, the mode of delivery, obstetric history, and some social demographic data. We also collect some data on the neonates, and like the birth weight at the time and the outcome of the baby in the end. This shows the sample size that we had used in the preliminary analysis in this case. So in total, we had 9,446. Then we are leaving out, those are missing information on this. and then we leave out of the first-time mother because the aim for the preliminary is just look at the multiparous women. We also saw this number, and then we leave out the one that are missing this information. Our outcome is derived from here. So it's a composite kind of outcome that contains neonatal deaths, infant deaths, the stillborns, miscarriages, termination, and ectopic pregnancies. So these are the kind of the input variables we are trying to put in the analysis. So we have age, all this, up to mode of delivery. So next, I'll show you the analysis plan that we have to put in place. We have two main analysis plans. We have the one for descriptive and predictive modeling. Remember my and predictive modeling. So for descriptive, we are looking at how do we summarize the variables using the frequencies, counts, and also the measures of displays like the median and interquartile ranges. We'll also compare the variables using a chi-square test of association. Then under predictive modeling, we divide the data into two, the test and training. And then for the training, we apply our modeling. And then we'll apply tenfold repeated cross-validation in the modeling stage. And we fit all these types of machine learning classifiers. Then once we fit the model, we test the evaluation using areas under curve and position curves. So all the analysis for the predictive modeling will use correct package in R. So this shows the descriptives for the characteristics that we have. You can see they are highly educated, medium to old age. They attended 4+ NC as required. These are the minimum requirements. And also, you can see majority have BMI above 28, which can be considered as an overweight. Then we look at the first objective, which was to the logistic regression. And you can see it's only getting malaria prophylaxis that is significant. So it shows that if you get the prophylaxis, your chances of getting adverse outcome is minimized by 23%. And then finally, we compare also the performance. That's our second objective. And you can see the two models almost perform the same. So our next steps, first we see from the output that intervention worked. And this calls for the issue to program team to enforce the issue of antenatal clinics so that they can get the prophylaxis. So our next steps in terms of analysis, we are going to fit more other classifiers. Remember, we only shown a logistic and a random forest. More to be done. That's work in progress. We're also going to continue modeling or training models for different groups. Remember, we left out the first-time mothers. So we are in the process to do the model for first-time mothers. And also, remember, we had like 5 facilities. We need to have facility-specific models also. That's our next step. And also, once we complete all this work, our aim is to validate our data in other private facilities that you have. And then finally, I can't go without acknowledging these people who have supported me in all this journey. And I can see they are well presented. Thanks so much.
Marwa is going to be moving around with microphone. So if you have questions, please indicate. And please note the questions down.
Well, thank you to all the scholars for the amazing presentations, and really for the African Studies Center for making this possible. I think it's really great to see people from very different backgrounds present in one setting, because we learn how to speak languages of each other. Yeah. And my question is to the first presenter. Sorry, I can't recall your name specifically.
Dr. Marissa Balmith.
Yes, Dr. Marissa. I was curious about the clonality of MCF7 cells, especially because the uptake of DNA by stem cells. Stem cells tend to be very recalcitrant to DNA uptake, and whether the clonality can have an impact on what cells take the DNA that you're delivering, and also how that might affect the homing of the cells into a specific organ, and whether MCF7 cells are more bone-centric, or whether there's evidence that they can also hone into other tissues.
All right, thank you. Yes.
Thank you. Likewise, thank you to all panelists for wonderful presentations. We are learning so many new things, and I'm asking a question of the second speaker, I think Tesfaye, which is a little bit outside of my zone of knowledge, so it might be a somewhat dumb question. But you showed the different styles of rock art: Saharan, the Horn, the Nile Valley, and South Africa. And it was called, I think, Styles and Timeline. So I was wondering if those styles were contemporaneous, or if they're also were in chronological order, and if you could very briefly speak to comparative work, because I know you have a South African mentor. We used to have somebody who specialized in Saharan rock art here.
Okay.
Thank you. And thank you to all our speakers for their lovely presentations, my fellow colleagues. I have questions for two of the speakers. The first one is for Marissa. Firstly, disclosure, I am a lawyer, so none of your areas are in my area of specialization. But Marissa, I just wanted to find out why you have chosen the specific treatment. I think you called it fulvestrant for purposes of your cells. And then James, I'm not sure if I lost you during the course of the presentation, but I wanted to just check, was your basic finding that the mortality comes down to not having received malaria prevention? Or is it a lot more nuanced than that? It may be, I may have just gotten lost because not my area, but I just wanted some clarity on that. Thank you.
Okay. Why don't we let the scholars respond first, then we'll move around again. Let's start with Tesfaye.
Okay. Okay, thank you for the questions. Maybe I can use like this. Yeah. I think the question is about the time frame or the chronology of the sites about the rock art site of Africa. Yeah, it may be very difficult to get the idea for the people who are out of the area or the specializations. Rock art is about the prehistoric period, and it belongs to the pastoral people especially. So it is associated with that of the beginning of domestication of plant and animals. So with regard to the time frame, in the Horns of Africa where I am working, it's hypothetically dated that rock artists in the Horn of Africa especially are dated from 5,000 BP to that of 1,000 before present. That is the idea where pastoralism was started in Africa. From our background, we know that the herding of cattle or animal domestication have been started in Near East, and then from Near East is introduced to the Africa. So In Near East, it is oldest than that of what the Horn of Africa or the other part of the Africa, because it follows the idea or the suggestion that rock art is depicted after the cattle herding or after the pastoralism. So we do have in Ethiopia two kinds of tentative dating is the one that I shown you, the Ethiopian rock art site, Ethio-Arabian style. The one is the earliest one, and the second one is that of the latest one. The earliest one is the one that dates from 3000 before Christ to that of 1000, and the others like that. So it's not contemporary, it's not the history of the contemporary, it is all about that of the prehistory.
Okay. Contemporary between the Sahara and Southern Africa. But we can talk about that later when I have the drawing here.
Okay. All right. So, James?
Okay, I'll respond to the question on the malaria prophylaxis. I think malaria prophylaxis is one of the interventions or one of the, how do you call them? The intervention that's given to women when they are pregnant and they go to NC. Another one is deworming. So our finding is showing that if you received that prophylaxis, your likelihood of having adverse outcome is reduced because it's the odds is 0.77, which is like 0.8. So that's like a 23% reduction in having adverse outcome. Yeah.
All right. Marissa?
Thank you for your question, firstly. So just a disclaimer, the cancer of stem cells is a new area for me as well. With that being said, I can just speak to what we've done in the laboratory and what we found. With the DNA uptake, we did not have any issues transfecting the MCF7 cells. I'm actually repeating some preliminary studies that were conducted. What I did find, however, though, was that I did lose fluorescent expression in my dual reporter cell line over time, which is now has led me to kind of re-transfect those cells from the beginning. So in terms of DNA uptake, I've not seen any issues with respect to the cancer stem cells. So I hope that answers your question.
So we can follow up later. So, yeah.
Second question about fulvestrant treatment. So it is currently used against estrogen receptor positive breast cancers. So basically it's an antagonist. So it will just bind to the estrogen receptor, block the receptor. So cells that require estrogen to grow will basically just slow down that growth. So essentially that is why it was chosen, and also because I was basically replicating some previous results, which is why we used it in this particular study as well.
All right, thank you. So, excuse me, colleagues online, colleagues and friends, please post your questions or use the raise hand button to indicate that you want to ask a question so that we'll call you. We can take more questions.
Thank you guys so much. I enjoyed all of your presentations, and I'm really excited to see what conclusions you all come to. So I have two questions. First is to Tesfaye. You showed us a map of some of the different rock art formations, and I noticed that they were kind of a few areas in the country, but they were all relatively clumped together, and I was wondering if there was a hypothesis as to why we're not seeing them spread out more throughout the country. And then also for Orwa, you included many factors that you examined in your research as to what may cause issues in birth, but you didn't include nutritional deficiency rates. And I was kind of curious as to why, especially with looking at BMI, and malaria, as to why maybe nutrition was left out, if there was any specific reason.
Okay, more questions?
Okay, so I'll add my voice to say thank you for the great presentation. So just a quick question to Marissa. We know there are other factors that could predispose a woman to recurrence or the metastasis. So how are you likely to be able to account for those in your work? Because, for instance, in a mouse, you're going to give some intracardiac immunosuppressant. That would suppress immunity, and that may not necessarily be present in the human being, for instance. So then, how do you account for the differences from the in vitro to in vivo? Thank you.
Okay, one more question.
Okay, great presentations from my colleagues over there. I appreciate your presentations. And to my colleague James, I'm wondering if there is a relationship between obesity and stillbirth. And then why was the set goals not achieved, if I heard you rightly? Did you find out why it wasn't achieved? Because if you don't find out, you will still not achieve it in 2030. So we would like to know why it wasn't achieved. And then to Marissa, I was trying to, is tumor initiating cell or cancer initiating cell and dormant tumor cells the same? Cancer tumor cells, cancer initiating cells and dormant tumor cells, are they the same? And then, is there a relationship between hypoxia? Did you look at the relationship between hypoxia and metastasis?
Okay, one more question. And John, I can throw out, excuse me, this question for you. The equations that you described up there, what does it do for heat conduction? That is the bedrock of your research.
Repeat again.
Yeah. So the equation that you showed us in your presentation, what does that do for heat conduction? Permit my ignorance. I know nothing about mathematics, but I just wanted to throw out that question out for you. So we'll start with Marissa this time around.
Okay, so to the first question, currently finding in vivo models that actually faithfully, I think, replicate what is happening with the clinical scenarios is quite complex because I think dormancy is just very multifactorial and it's quite a complex process. We use immunocompetent mice. They're just easier to grow tumors in at this stage, though it's not always easy to fully replicate what is happening from an in vivo environment to a clinical scenario. Jude's question on whether or not hypoxia and metastasis is related, we haven't investigated that in this particular study, but there are studies that are currently ongoing in the lab that will be looking at that specific hypoxia or in metastasis. And then your question on cancer tumor cells, and I think it is the dormant cells? Cancer initiating cells and the dormant cells. From what I've seen, there are evidence that do link them up. However, I'll have to look into that question further to be able to provide a substantial answer.
All right, James.
Okay, thanks, Jude, for the two questions. I think achieving these targets for SDG needs a lot of factors. And one of them is the health system structure. Because this starts from the community setup. If the referrals are not properly made at the community level to the facilities so that they can access the services, still will not achieve that. If our healthcare workers are not well trained to provide quality services whenever the mothers reach the facility, still not achieve this. So it's a lot of multifaceted factors that can influence the achieving all this. And again, sometimes most of the women go at advanced stage. If you follow the history of NC, mostly go through the second or third NC visits, like NC trimester, instead of doing the first early trimester, especially in Sub-Saharan Africa. So if they can start early, they'll go through all the stages, all of the packages required for antenatal care. But if they come late, they'll miss this. And that's why WHO recommended that they should have like 8 contacts and like 4 before. That's one way trying to achieve the goals that we are there. About obesity being not a factor, I don't want to explain this, but That's what you could see, that from the preliminary data that you have, being obese at that point is one factor explaining the adverse outcome. But this could be attributed because of the stage, because I think when women pregnant, they add weight. I think so. I'm arguing from the perspective of statistician, but maybe you can contact the content people, the programmatic, to help us explain this, or the physicians. I think at that stage they gain more weight, and now it could be obese because of the pregnancy they do have, not the actual obesity when they're not pregnant. Maybe for obesity.
Okay. Tesfaye?
Okay, thank you for the question. Why not rockart throughout Ethiopia? I think you asked the question starting from the map, which shows the distribution of rockart in Ethiopia. Yeah. Previously, people were focusing on or going on those areas which are already discovered, and there was no attempt to discover new rockart sites in the country. But there is a potential still to recover more archaeological, rockart sites in the country. The problem is that these rockart sites are located or found in remote areas. They are not accessible, and they are not visible or open. Because of this fact, I think all of the rockart sites in the country are not discovered, and there will be a lot. And now I think it started to change the already established map, because we have got now 4 rockart sites, and I think we'll have more in the same area that's in the Nile Valley. Therefore, the problem is because of the inaccessibility of these sites, and because of the commitment of the archaeologists, they focus on all the already discovered archaeological sites. That's the problem, I think.
All right. John?
Yeah, so you asked what's the relation between the equation that was my slide and heat conduction. So normally the equation that was on the slide, it's a heat equation. That's a simple equation which is in a partial differential equation that shows how the heat transfers from one point to another point. Normally in application, heat transfer from one point, which is the Coulomb point, to the other point. So now if you attach this kind of boundary condition depending on the geometry you have, so you have heat equation with some boundary conditions. So now if you try now to recover some surface temperature, or for example the coefficients, thermal conductivity or specific capacity, now it becomes inverse heat conduction problem.
Okay, thank you. We have time for just one more question.
Okay, thank you guys for the lovely presentations as well. So I think my question will go to James. So I think I have 2 questions. So the first one is, maybe I don't know if I missed it or whatnot. Why were you using multiple models? Were you trying to see which one had the best outcome, or what was the rationale behind using all of those different models? I don't know if I missed that one. And the second one is just out of curiosity, because now we're all knee deep in ethical clearance, in terms of how did you go about anonymizing the data? What is the process there? Because that's part of what I'm working on now. So how do you go about now? You're dealing with these people, you're getting personal data from them. How do you go about the privacy concerns there and anonymizing the data? Thank you.
Thank you. John? Sorry.
Okay,
James.
I'll start with the simpler one. So the one I'll respond to first, the simpler one. So in terms of multiple models, you want to see how these models performs in predicting a woman to be at risk of having adverse outcome. So we try different models and check the accuracy. Remember I said that we'll be assessing also the precision curves and also looking at the area under curves in that case. That's why we try several models for that. We also know that some are not very good, like bugging has issues, but we still do it and see how it performs. We also know that there's a bias variance trade-off between in logistic regression, but we still fit it. So just compare and see how it performs. That's why you do several models and see which one gives the right prediction in terms of accuracy. On anonymity of the data, that's key. And then we don't collect any personal information in the data. So what you do, each patient is identified by, we call them AKU number, that's hospital PID, patient identification number. But in the analysis, this is randomized again, and we strip them off before the analysis. So make sure the data is anonymized, and also all our data also are run in the clouds, and the cloud are not allow us to do any path modification before storing the data in the clouds. So we do a lot of anonymity in the data before it's stored there.
All right, thank you very much. We've come to the end of today's colloquium, and just a quick announcement. On Thursday, same time, next week, we'll be hosting another colloquium. And the theme of that one is theater, race-linked genomics, and consumer protection in Africa. And three of our scholars, Judo Koye from Nigeria, Tepiso Scott from South Africa, and Jerusalem Kasahun from Ethiopia will be presenting. And we hope that you all join us here again. And finally, I would like to thank my colleagues at the ASC, Teye Pam, who coordinates the UMAPS program, Marwa Hassan, who is the academic specialist, and Andres Kwaze, who is online with us. Thanks for putting all of this together. We appreciate the work you do for the ASC. And thank you, everyone. Please join us for a refreshment and reception in the corner of this hall, and we hope to see you again next week. And let's put our hands together for our scholars. Thank you very much.